Okay, so we're going to add some functionality now from a camera perspective, so we can get the character moving with camera input as well. For that, we're going to need two new scripts. The first one being a third-person camera script, and the second one being an extension script. Oh, apologies. There we go. Let's add another script and camera extensions. And we'll start just by opening both of these up. So we've got complete visibility in our scripts. Now we're going to need to make some adjustments to our existing scripts to get this to work. So if we start first off in the third person input, and we're just going to need to add another couple of variables in much the same way as we did with the inputs here. So we're going to need inputs for the camera, and in the same way that I use existing horizontal and vertical, I'm going to be using the existing mouse inputs with this here. So again, this just adds in, let's just get rid of that, this just adds in a header in the inspector, and then I'm just pulling the mouse X and mouse Y. We're also going to need reference to this script, so again, similarly to how we did with the character controller, we're just going to drop in reference to the third person camera script, and then at the start we're going to need to assign that camera the same way as we did here with the character controller. Okay, so once those are in, the next thing we're going to need to do is exchange this function in the input handle with a camera input function. Okay, so we're actually going to remove this completely, and the camera input function is going to contain this function, which we're going to add to in the character controller as well. So if we exchange that for a camera input function, and in the camera input function, again guys, I'm just copying and pasting code over, so you don't have to watch me type. Some of it I've commented if it's a little bit more tricky, so do feel free to pause and just read through the comments if I'm missing anything. So let's drop the camera input function in and we'll go through it. So the camera input function is just going to check that there is a camera, and it's going to assign an X and Y value in there. It's going to call this rotate camera function, and then it's going to call the update target direction function that we've just replaced, passing in the variables for the third person camera. Okay, so we'll need to make some changes to this, and we'll need to rewrite this. So first off, let's go over to the character controller and update this update target direction function. Okay, so in our update target direction function in the character controller script, we're going to want to add in a transform for our camera that we're passing in. So we're going to want to drop that in there, and then we're going to want to update the actual function itself. So if I pull this in here, so this bit is doing what we were doing before. So if the transform reference is null, we're going to drop back down to here and it's going to work as it was before. But while we've got a camera, we're going to pass in its transform details, and we're going to take its forward transform vector and its right vector. We're going to multiply those by our existing X and Y inputs and create a new target direction. So as the camera moves, our target direction will move too. We can save that out as the character controller, because now that's updated. That's all we're doing in here, and that's all we're also doing in the third person input also. So now to move on to the third person camera script and get this rotate camera function added into there. As with all of our other scripts, we're going to need some variables to begin with that we're going to use throughout this section of code. So to start with, we'll just delete our start and update functions. We'll put our own in as we go, and let's just drop our section of variables straight in, and I'll go through them very quickly. They're all relatively straightforward. So we need a target, which we'll allocate in the inspector later. Our camera itself, some positions we need to look at. I'm just hiding these in the inspector. We don't need to see them during gameplay, we just need to know they're there. Some basic movement and positioning variables, all pretty straightforward. A variable to hold our movement speed and positions. the clamp angles for our maximum rotations, so we don't want to go over the top of our player or too far underneath them. We need to set our culling layer. So this is the actual layer that we'd have set earlier on when tagging the walls. With that layer itself, this is going to be very important when we start to raycast, so we know exactly what it is we're hitting. And some variables for culling distance and height, and then just some smooth rotation stuff. So once we've got all of our variables in, let's drop the rotate camera function in that we came in here for. And the rotate camera function is quite simply just going to set the mouse X and mouse Y to the X and Y multiplied by the mouse sensitivity, which we set up here to 3. And then it's going to run the clamp angle on these mouse X and mouse Y to make sure that we're not going over or under those limits. So let's head on over to the camera extensions script and let's get these functions working. Okay, so our camera extensions script is going to be slightly different to the other scripts that we've looked at. This one in fact is going to exist in a namespace that's going to be the camera extensions namespace. And let's just wrap this up in brackets. And it's also not going to be a public class that inherits from mono behavior. In fact, it's not going to inherit at all. It's going to be a public static class that we are going to call extensions. And for the time being, we can also get rid of the start and update functions. We're not actually going to use those. We're going to write our own in. And the first one that we're going to need to write in is this clamp angle function. So we can actually get this working and stop it erroring on us. So the clamp angle function is pretty straightforward. We're going to pass our angle in as well as our minimum and maximum angles that we predefined in our variables earlier on. And this angle is going to come in and we're just going to make sure that we're not less than minus 360 or greater than 360. So this is just going to loop through and make sure that we wrap around if we are outside a range. And once we're within that range, we're just going to clamp the angle to somewhere between the minimum and the maximum with a built-in Unity function that already exists. Once we've done that, the clamp angle function will work. We just need to make sure that we include that namespace. So if we scroll back up to the top and add in a using camera extensions like that, this script will then be able to see this namespace and this function will work just fine. So continuing on with the third person camera script, let's see if we can actually get some fixed updates involved. So we're going to move the camera always on a fixed update for the same reason as I mentioned earlier. So we want everything else finished before we actually try and move the camera anywhere. So on a fixed update, we're just going to check that we've got both a target and a target look at to make sure that there's something for us to actually focus on. And if we do, then we're going to run our camera movement function. Okay, so this is our camera movement function and we'll go through it line by line so we can fully understand it. So to start with, we're going to want to constantly setting our distance. So ideally with the camera being moved around, it's going to start culling into walls and shifting. The distance will change, but we want to constantly be trying to get back to our default distance. So there's going to be a permanent lerp on that to try and push it back to where we want it to be. Then we grab our target position, which is going to be our player in this instance, or whatever it is you set the target to. And I'm just going to change that ever so slightly with the focal height that I set out earlier on. I don't want the camera pointing at his feet or his waist. I want it pointing kind of upper, middle, back. So I'm just going to raise it up a little bit there. Then we get our camera direction. I've negated this value because it's multiplied by distance down here. And we obviously want the camera behind our player. And if we multiply a positive direction, a positive vector 3 with a positive distance, I'm going to end up in front of my character and I won't be able to see him. So that's the reason that's negated. It's used, this calculation is used in a few different areas, so it seemed easier to negate this vector as that's the only time that's really used. And then we reach the first function that that we haven't written yet, that's going to live in our extensions namespace again. So this is going to be the clip-in plane points, which is going to work out the four corners of our screen, or the four corners at least of our camera, so that we can really tell from all four corners what the camera is capable of seeing through to the target position. So 100% if anything is in our way. So let's head on over to the extensions and let's write out these functions. For our clipping plane points, we're going to want a struct to begin with that actually holds all of them. So as I mentioned before, it's going to be the four corners, so upper and lower, left and right. And I'm going to add a fifth plane point in, which is going to be the center. That's going to cast directly from the middle of our camera through into the center of our focal point on the guy's back, just to make sure that we've always got at least some visual of him. So that's going to hold our clipping plane points. Now we just need to actually write the function for getting exactly where those clipping plane points are. So let's drop that function in and we'll work through it. So to start with, we're going to pass in the camera and we're going to pass in the position of the camera. I've used variance characters here, and I probably shouldn't have. So let's just correct these as I go, just to make sure that we're using the correct types. So we're going to grab a new clip plane points, which is going to contain these 5 vector 3s, and we're going to assign them down here. So first off, we're going to get the transform of the camera, so that's going to be a transform, which gives us access to its up and forward vectors, and then from there these are all just floating point values. So with a little bit of trigonometry, we can actually work out exactly where the corners need to be. So if we take the half field of view from our field of view, looking straight forward at the screen, if we take half of it, when it meets the screen, you actually end up with a right angle triangle. So using our sin, cos and tan, we can actually take the distance, which we already know, that's the clip planes value that's actually held in the inspector. We can take the distance and we can multiply it by the tangent of the half field of view, which we've got from up here, and that then gives us the height. And then with the height times the aspect ratio, which again is contained in this camera object, we get the width as well. So we've got everything we need from these few calculations to actually be able to just push the points from the center up and across and up and to the right and equally down and to either corner. So all these are doing is basically just pushing the position of our vector 3 that we pass into the middle of our camera, up and over and forward the distance, so we're getting right on exactly where the start of our clip plane point is. And equally over to the left, we just negate our transform right, and upper right is a positive on the transform up, and upper left just negates the transform right again. And then finally we've got our final clip plane point, which, as I mentioned, literally just goes from the middle of the camera. So all we're doing is we're pushing it forward to where the start of the clip plane points is, which I think I've got mine set to 0.1, I want to say. You can see them in here. Okay, 0.3. So that's the value that would get passed in, and that can just be adjusted here, and it will equally just adjust the other values. Okay, so if we go back to this, that is everything that we actually need to add to our extensions namespace. So if we save that one's actually done. So this function will now work. So we can now carry on through our camera movement script and see what else we've got. So now we've got our clip and plane points. We can actually raycast from those four corners of our screen towards the target towards the focal point on the back of our guy and around him. But to do that, we need to write this function. So that's exactly what this function is going to do. It's going to cast a ray from our target position up towards our clip points, and that direction is quite important because it's going to bring back the distance that anything has got in our way, and we want the distance from the player to the object, not from the camera to the object. So that way around is quite important. It's going to return the hit info, which is going to be the distance, and we're going to cast the ray, the distance from the player to the camera, plus a little bit. The reason for the little bit is because we want to make sure that there's definitely nothing in the way. So if the camera is almost exactly in line with a ceiling, we don't want that to be okay. So we want to make sure that there's nothing directly above our heads as well. Otherwise, you're gonna start playing, and a camera is going to be like right on the camera, and it's not going to look very good. So we just cast up that extra little bit just to give us a little bit of head clearance when the camera runs under a ceiling. We're passing in our culling layer to make sure that if we hit anything that's layered as a wall, those are the things that we're interested in. Anything else, we don't really care. And I'm passing in a color so that we can actually do some debugs as well, so we can actually see these ray casts in action and see what they're doing. Okay, so let's write this function out so we can carry on, and let's see what this function does. So if we scroll down to the bottom, it's all going to be contained for this one in the same script, and it does seem like a bit of a bigger script, but again, it's nothing too major. We'll talk through it, it'll be fine. So this is our culling raycast function. It's taking everything that we mentioned just above. We're going to set all of our initial Boolean values to false, so we're going to assume that we don't hit anything. Okay, so we've got our lower left, lower right, upper left and upper right, and this one is going to be for our center cast, our middle character. Okay, so the first one that we're going to draw and the first one that we're going to cast to is the one to the middle of our character. So we're going to debug, we're going to draw a ray through. So we're going to go from the center to the center point, which is where our clipping planes are, minus the center, which gives us our relative point in space compared to the center of our character. Okay, I'm going to color that one red just so it's slightly different to the blue that we passed in, just so it stands out. And we're going to do the same with the physics raycast, but we're going to pass in the culling layer and the distance just to make sure that we're casting the right amount. If that hits anything, we want to return the value as true, and we also want to change the culling distance, which we will come back to later, but essentially if we hit anything and that value is true, that culling distance is going to make the camera snap forward and get out of its way, because that means if the middle's hit, we're pretty much completely occluded. We actually can't see our player, so we need to change that quickly. Once that one's been done, we're going to check to see if we're moving, because these bottom functions, the outside raycasts, are only really going to come into effect when we're moving, because they're going to force the camera to actually move gently out of the way. If there's a bridge or a low ceiling, it's actually going to push us up and down out of the way, which we're only really interested in if we're actually moving anywhere. So we're going to check our velocity, our rigid body's magnitude, to see if there is any forward movement. And if there is, so I've used the epsilon from the math function. You could quite as easily just type in a very small floating point value there, it would work just fine. And then we're pretty much just going to repeat the sequence that we've done up here, but for the four corners. And the only other thing that we're going to have to make sure that we do is change the point. So our center point up here that we cast to, what we want to do is we want to be able to cast just outside of the range of our character. So in this case, if anything occludes our character's head, it's not going to make any difference. It's only going to kick in when something occludes the midsection of him, his upper back, where we've got this going to. Whereas with these, because we want the camera to actually gently move downwards and out of the way, or upwards and out of the way, we want to be able to kind of cast up above his head and kind of down by his knees almost, to make sure that if his head starts getting covered, our camera starts moving down out of the way, so we keep him in range. So all I've done is used our focal range from before. So if I scroll all the way back up, this range here that I mentioned briefly before, this is what's going to push our points upwards by 0.7. If you remember, half of our guy was 0.9, so I'm starting at his upper back, so I'm already over halfway. I'm going up 0.7, so I'm going to be just over above his head, and I'm also going to go down 0.7, so I'm going to be kind of by his knees somewhere. And I'm also going to push out to the left and right by 0.2, so I'm going to be kind of over his shoulders, above his head, and kind of leg width down by his knees. So that's what that focal range is doing there. So I'm pushing for the bottom left. I'm going to go negative on the Y and negative on the X, and then this just repeats for the lower right, the upper left, and the upper right. And if we get a hit on any of these, it turns the individual Boolean value to true, which then leads us on to our next point. So the camera itself, we only want to move it down if his head is completely covered, or if there's like a bridge in the way. If there's just kind of a branch coming out from a tree or something like that, and it only hits one, we don't need to start bobbing our camera out of the way if kind of just a corner of his head is covered. We want his head to be going kind of under a bridge or something similar. So both of the uppers need to hit, or both of the lowers need to hit for us to start pitching that camera up and down. So if the upper left and the upper right hit, we're going to set the move down to true, so we're going to start telling our camera to move down. And importantly, we're going to set the Y max limit, so where we clamp our Y angle, we're going to set that to our current mouse Y minus our occlusion speed. So whatever we're trying to move down by, we're going to stop our camera from moving back up into the ceiling. As soon as that becomes false and we've cleared whatever it is that we're going under or that's going over the top of us, we're going to reset those values and allow the clamping limit just to go back to its default again, so we've got full movement. Exactly the same with the lower limits, and then we're just going to return this Boolean value from the initial hit, this one. Okay, so that tells us if we've hit anything. Alright, cool, so that function is now working. So once this has ran, if it's hit anything, we're going to come in, and if the move up or move down Boolean values have changed, we're going to directly affect the cam Y, which we played around with a little bit earlier, setting it to the mouse input with the clamp angles on the min and max limits. We're going to either push those up or down depending on if we've hit anything on either the up or the down sections of those raycasts by the occlusion speed. And if we've still hit anything, if we hit anything with our center point, the culling distance would have been set to a distance from the back of the character to whatever it is we hit, to one of the walls. So we're going to set our culling distance to a lerp between the current distance and the distance that's just been set, and then we're going to set the distance to this lerped value of the culling distance. So we're going to pull ourselves forward nice and quickly. We're just going straight over delta time, so that's going to be quite a fast movement forwards if there's anything in our way still at this point. Once that's done, we're just going to deal with the rotation, the final setting of the position of the camera. So we're going to get a new rotation on a quaternion. We're going to set that to a Euler angle from the X and Y components of the cam, which we've been pushing around with our mouse, and the move up and move down. So that's going to set our rotation. We're going to change our target lookout rotation to a slurp between the new rotation and its current rotation. This, if you remember, directly affects the forward for the camera direction, which equally sets its distance backwards. So this is actually going to push us round based on this value as we go through. So we're going to be making sure that we go backwards from the new rotation as this loops around, and then we're going to set a final rotation for the camera itself to make sure that we actually turn as well as push back in the right direction. And then we're just going to set our transforms rotation to this new quaternion. From there, the only thing left to do would be to actually initialize our camera. So right at the beginning, we're just going to need a start function, and that start function is going to run an initialize function. You could just stick this straight in start, but I like to keep the main functions, the built-in functions, nice and tidy. So we'll drop the initialize function in, which is just going to set everything up for us. So we're going to make sure that we've assigned a target, which in this case is going to be our player. We're going to grab the camera object, we're going to set our target position to our player, and we're going to create the camera's target at this point. This is essentially just a direct replica of our player in terms of the position and the rotation, but it does allow us to manipulate it without needing to manipulate the target position. And then this way as well, if we ever need to change the target position, it makes it much easier. So we create a new game object, we align its position and rotation with that of our target, and we hide it in the hierarchy because we don't need to see it, we just need to be able to reference it. From there we initialize our mouse X and Y, set our distance to the default, set our camera rotation limits, and we grab the rigid body for the player. Once all of that's in, our camera's initialized, all of our functions are set, and we should be good to go. So if we save that down, and we'll pop back over to our Unity project and get our camera running. So back in Unity, there's a few things that you're going to need to do to finally get the camera set up. If we click on the camera in the hierarchy, and with the third person camera script that we've been working on, if we drag and drop that in and add it as a component, and then we'll just need to set the target. So if we drag and drop our SWAT guy onto the target, from here if we press play, we should have a fully functioning camera. Okay, cool. So it looks like we've got camera movement and camera rotation. We can dip down and not go too far over or under, which is great. Okay, so you can see in the scene up there the red debug line, which is casting to the kind of the upper back of my character. That's going to be our main occlusion. So if anything gets in the way of that, our camera is going to snap forward. Now, as I walk, you can see those debug lines are going from the clipping plane points on my camera through to just above his head about shoulder width and down by his legs about knee width. So those are going to check to see if there's anything that we're going to walk into. Okay, so if we just move this main camera up and over here so we can see what's going on, and we just give this a test. So if I spin this around and walk towards, remember as we're walking, his magnitude is greater than the epsilon, so we're getting those extra raycasts starting to kick out to see if anything gets in the way. So as we move towards this, they're going to hit that and they're going to lerp downwards out the way, which gives us a nice movement underneath here. If I run towards it, we'll pick back up again and you'll just see it lerp underneath. If I'm sat under here and I stop, so I've only got the red line, as I come in, if I hit a wall, it's just going to start clipping in and getting me away from those walls. Okay. Alright, it looks like it's working well. Thanks for watching, guys. Tune in for part 3 where we're going to be looking at some first person camera and switching between first and third and the movements for our character that go with that.